Hey guys, tonight we're diving deep into one of the most haunting, mysterious, and world shaping forces in human history: pandemics and viruses. From the shadows of ancient empires to the bright laboratories of the modern age, diseases have risen, evolved, and rewritten our story. So before you get too comfortable, take a moment to like and subscribe, but only if you enjoy the kind of content that merges myth and mystery. And hey, let us know where you're watching from. What time is it for you right now? It's time to dim the lights, and together, let's uncover what we have for tonight. When we speak of pandemics and outbreaks, the first thing we must understand is the true nature of the enemy. Viruses are among the most fascinating, yet most terrifying, forms of life, or perhaps more accurately, forms of existence on our planet. Unlike bacteria or other microorganisms that can live independently, viruses occupy a liminal space between life and non-life. They are tiny molecular machines, often only a few hundred nanometers in size, invisible even to the most powerful optical microscopes. Yet despite their minuscule scale, viruses have the power to shape civilizations, alter history, and even leave traces in the very DNA of the humans who survive them. At their core, viruses are extraordinarily simple. Each virus consists of genetic material, either DNA or RNA, enclosed in a protein coat called a capsid. Some viruses are further enveloped in a layer of lipids, which helps them infiltrate host cells. Unlike bacteria, fungi, or parasites, viruses cannot reproduce on their own. They are entirely dependent on a host, whether it be a single-celled organism, an animal, or a human. In that sense, viruses are biological opportunists. They exist to enter, hijack, and replicate within cells. Once inside, they release their genetic instructions, turning the host cell into a virus-producing factory. It is this parasitic relationship that makes them so formidable and, in many cases, so deadly. Viruses are masters of adaptation. Their genetic material is prone to mutation, sometimes so rapidly that the immune system struggles to recognize them. Influenza, for example, mutates frequently, giving rise to seasonal flu outbreaks and occasional pandemics. RNA viruses, in particular, are especially prone to mutation due to the lack of proofreading mechanisms during replication. This rapid evolution allows viruses to evade immunity, jump between species, and in some cases, increase their virulence. It is precisely this capacity for change that has made viruses persistent companions of humanity for millennia. Our understanding of viruses is relatively recent in the grand timeline of human history. In the late 19th century, scientists such as Dmitry Ivanovsky and Martinus Beijerinck began noticing infectious agents smaller than bacteria, capable of passing through filters that trapped all known microbes. Beijerinck coined the term contagium vivum fluidum, recognizing that these agents were alive in a very different sense from traditional organisms. It wasn't until the invention of the electron microscope in the 1930s that the structure of viruses could be observed directly, revealing their geometric shapes and astonishing diversity. Some resemble tiny spheres, others form rods, and some even appear as complex polyhedral shells, as if designed with a precision no human engineering could match. The study of viruses is not merely an academic pursuit. It has profoundly shaped medicine, immunology, and our understanding of life itself. Viruses are responsible for some of the deadliest pandemics in human history, from smallpox and influenza to Ebola and COVID-19. They have altered the course of wars, devastated populations, and influenced the rise and fall of empires. Yet, paradoxically, viruses are also indispensable tools in modern science. They are used in gene therapy, vaccine development, and even as vectors in cutting-edge cancer research. In other words, understanding viruses is not only a matter of survival, it is a gateway to unlocking the deepest mysteries of biology. One of the most remarkable aspects of viruses is their ubiquity. They exist in almost every environment on Earth, from the depths of the ocean to the upper atmosphere. It is estimated that there are over 1031 viruses on the planet, a number so large it is difficult to comprehend. Most of these viruses infect bacteria, archaea, or other microorganisms, playing crucial roles in regulating ecosystems and nutrient cycles. Yet a small fraction of viruses are capable of infecting humans, and within this fraction lie the pathogens capable of triggering epidemics and pandemics. The delicate balance between these harmless and harmful viruses has shaped both life and the course of history in ways we are only beginning to understand. Another critical concept is how viruses spread. They can move from person to person through droplets, aerosols, contact with contaminated surfaces, bodily fluids, or even through vectors such as mosquitoes. Some viruses, like influenza, are highly contagious and can move quickly through populations. Others, such as HIV, require more specific conditions to transmit, yet they can persist and devastate societies over decades. The modes of transmission influence the impact of each virus and often determine the strategies humans must employ to prevent outbreaks. Sanitation, vaccination, and quarantine have all been humanity's tools in this ongoing battle. Viruses also demonstrate an extraordinary ability to cross species boundaries. Zoonotic viruses, those that jump from animals to humans, have been the source of some of the most significant pandemics, including HIV, SARS, MERS, and COVID-19. This cross-species transmission is facilitated by genetic mutations, close contact with animals, and environmental disruption. As humans encroach on forests and wildlife habitats, the opportunities for zoonotic spillover increase, highlighting the interconnectedness of human health, animal health, and the environment. Understanding viruses, therefore, is not just about treating diseases. It is about understanding the complex ecosystem in which we all exist. Throughout history, viruses have left their mark not only in mortality statistics, but also in culture, religion, and human thought. Societies have sought explanations for mysterious illnesses in divine wrath, miasmas, or curses, long before microbiology offered answers. Art, literature, and philosophy have been shaped by recurring epidemics, reflecting human fear, resilience, and creativity in the face of invisible enemies. In a sense, viruses have influenced not only biology and medicine, but also the very way humans perceive life, death, and our place in the world. In the modern era, humanity has made unprecedented strides in understanding and combating viral diseases. Vaccines have eradicated smallpox, nearly eliminated polio, and controlled countless other viral infections. Antiviral medications and public health strategies have limited the impact of influenza, HIV, and emerging pathogens. Yet, as recent outbreaks remind us, viruses are always evolving, and new threats emerge unpredictably. The lesson is clear: knowledge, vigilance, and adaptability are our most potent weapons against these microscopic adversaries. By examining the biology of viruses, their modes of transmission, and their historical impact, we begin to grasp the scale of the challenges humanity has faced and continues to face. Viruses are not merely invisible, they are ubiquitous, adaptive, and profoundly influential. They remind us that even the smallest entities can alter the trajectory of human civilization. As we move forward into the study of pandemics through history, this foundational understanding provides the lens through which we can appreciate both the peril and the ingenuity that have defined humanity's response to these relentless, invisible enemies. Long before humans recorded their histories on clay tablets, papyrus, or paper, disease was quietly shaping the course of our species. Prehistoric humans, living in small nomadic bands or early agricultural settlements, faced pathogens that modern science is only beginning to reconstruct. These early diseases were largely invisible, leaving no written record, yet they left marks in bones, teeth, and even our DNA, whispering stories of survival, adaptation, and evolutionary pressure. Paleopathology, the study of ancient diseases through skeletal remains, provides our first glimpses into these long-lost pandemics. Archaeologists have discovered evidence of tuberculosis, leprosy, and treponemal diseases in remains tens of thousands of years old. For example, lesions on the spines of Neolithic skeletons suggest that tuberculosis, a bacterial disease, was already present in human populations before written history. Similarly, dental and bone abnormalities indicate the presence of chronic infections, which would have weakened early communities, making them vulnerable to other pathogens. Even without direct evidence, genetic studies hint at the existence of viral pathogens that left no skeletal trace, silently influencing human evolution. Among the earliest infectious diseases likely to affect humans were those that could jump from animals to humans. Zoonotic transmission, when pathogens transfer between species, has been a defining feature of human disease since the dawn of our species. As early humans domesticated animals for food, labor, and companionship, they inadvertently brought themselves into contact with new pathogens. Measles, smallpox, and influenza likely originated from animals such as cows, pigs, or birds. In small, isolated hunter-gatherer groups, these diseases may have caused sporadic outbreaks, but as populations grew and agriculture created permanent settlements, epidemics became more possible. The Neolithic Revolution, beginning around 10,000 years ago, marks a pivotal moment in the history of infectious disease. The shift from nomadic lifestyles to farming communities concentrated humans, animals, and waste in close proximity. This created an environment in which pathogens could spread more easily and persist from generation to generation. Waterborne diseases, such as cholera and parasitic infections, became more common, while respiratory illnesses found new opportunities to travel between crowded dwellings. Essentially, The very act of creating civilization provided pathogens with the conditions they needed to thrive. Interestingly, some of the most ancient viral infections have left their mark directly in our genome. Endogenous retroviruses, viral sequences embedded in human DNA, offer a molecular fossil record of past pandemics. These sequences, passed down through countless generations, provide clues about how ancient viruses interacted with humans, how our immune systems responded, and even how viruses may have shaped human evolution. Scientists estimate that nearly 8% of human DNA consists of these viral remnants, a silent testament to our long-standing battle with invisible enemies. Early humans also faced environmental pressures that intensified the effects of disease. Malnutrition, exposure to harsh climates, and limited medical knowledge meant that even relatively mild infections could be deadly. Infant and child mortality were particularly high, with many young lives lost to diseases that modern medicine now treats as routine. Communities that survived these early epidemics developed cultural strategies to cope, including ritual practices, isolation of the sick, and the creation of taboos around certain animals or behaviors, precursors to public health interventions. Trade routes, even in prehistoric times, played a significant role in spreading pathogens. While small groups may have experienced localized outbreaks, the movement of goods, animals, and people allowed diseases to leap across regions. Archaeological evidence suggests that tuberculosis and leprosy traveled alongside early human migrations out of Africa and across Eurasia. These pathogens evolved alongside humans, adapting to new environments and new hosts, demonstrating the remarkable coevolution of humans and viruses. Despite the lack of written records, prehistoric diseases profoundly influenced human societies. Populations were shaped by recurring outbreaks, survival pressures influenced genetic diversity, and social structures were molded by the need to cope with illness. Even myths and early spiritual practices may have been responses to disease, as early humans sought explanations for sudden death, infant mortality, or mysterious symptoms. The fear of unseen forces, the rituals to appease gods or spirits, and the social taboos surrounding illness all suggest that disease was not only a biological reality, but also a cultural one. Modern science continues to uncover new insights into these forgotten pandemics. Ancient DNA sequencing allows researchers to reconstruct pathogens from skeletal remains, revealing the genetics of ancient strains and their relationships to modern viruses. Studies of prehistoric tuberculosis, for example, have shown that strains of the bacterium were already highly diverse thousands of years ago, suggesting complex patterns of transmission and adaptation. Similarly, evidence of smallpox-like infections in Egyptian mummies demonstrates that even civilizations that followed the prehistoric era were still contending with diseases that had ancient origins. One of the most striking lessons from prehistoric pandemics is the persistence and resilience of viruses. Even in small, dispersed populations, pathogens found ways to survive, mutate, and reemerge over millennia. The challenges faced by our ancestors laid the foundation for humanity's ongoing struggle with infectious diseases. Each wave of infection, each adaptation by the human immune system, and each behavioral adjustment contributed to the evolutionary arms race between humans and pathogens. a race that continues to this day. By examining the diseases of prehistory, we gain perspective on the scale and scope of human vulnerability. Viruses and pathogens were not just incidental nuisances, they were active forces shaping survival, evolution, and culture. They remind us that even in an age without cities, trade, or advanced technology, the invisible enemies were ever present, quietly influencing the path of humanity. Understanding this ancient history provides essential context for the pandemics that would later become historically documented and globally transformative. Prehistoric diseases also underscore the interconnectedness of humans, animals, and the environment. The patterns of transmission observed thousands of years ago are echoed in modern zoonotic outbreaks, illustrating that the factors contributing to pandemics, population density, close contact with animals, ecological disruption, are not new phenomena. They are part of a long continuum, stretching from prehistoric times to the contemporary era, and studying them offers crucial lessons for prevention and preparedness. In summary, the diseases of prehistory were both invisible and immensely influential. They shaped human evolution, social structures, cultural practices, and the very DNA of our species. While we may never know every detail of these ancient pathogens, the evidence we do have provides a window into the earliest interactions between humans and viruses. These early encounters laid the groundwork for the recurring theme of pandemics throughout history, a theme that we will continue to explore in the coming sections, tracing the journey from the shadows of prehistory to the documented crises of classical civilizations. In 430 BCE, as the city-state of Athens stood at the height of its political, cultural, and military influence, a mysterious and devastating disease arrived that would shake the foundations of one of history's greatest civilizations. Known to history as the Plague of Athens, this epidemic struck during the second year of the Peloponnesian War, a brutal conflict between Athens and Sparta. While the war itself was catastrophic, the arrival of the plague introduced an entirely new kind of threat, one that no army, no strategy, and no fortification could fully defend against. The origins of the plague remain a matter of debate even today. Ancient historian Thucydides, who survived the disease and provided the only contemporary account, described its symptoms in painstaking detail: fever, inflammation of the eyes, bleeding from the throat and tongue, severe vomiting, pustules on the body, extreme thirst, and delirium leading to death within days in many cases. Thucydides also noted the psychological and social effects: panic, despair, and the breakdown of traditional religious and social norms. Entire families were wiped out, funeral rites were abandoned, and civic cohesion began to crumble. In his words, the strongest bodies, and those in the prime of life, were the first to be destroyed. Modern scientists and epidemiologists have attempted to identify the causative agent of the plague. Though certainty remains elusive, various hypotheses have been proposed, including typhus, typhoid fever, smallpox, measles, or even Ebola-like viral hemorrhagic fevers. Recent DNA analysis of dental pulp from ancient Athenian graves has suggested a possible link to Salmonella enterica, the bacterium responsible for typhoid fever. Regardless of the precise pathogen, what is clear is that the disease spread rapidly through the densely populated city of Athens, killing perhaps as much as a quarter of the population. Estimates range from 75,000 to 100,000 people. The societal impact of the plague was profound. Athens, already strained by war and siege, found itself unable to sustain its military campaigns or maintain civic order. Soldiers who remained healthy were often reluctant to fight, fearful of exposure. Religious practices and temples were abandoned as people struggled to understand why the gods had allowed such suffering. The traditional framework of law, morality, and social cohesion began to fray, with reports of looting, lawlessness, and the abandonment of moral codes emerging from Thucydides' accounts. In short, the city was paralyzed, not just physically, but socially and psychologically. The plague of Athens also had significant political consequences. Pericles, the leading statesman of Athens at the time, succumbed to the disease in 429 BCE, leaving a leadership vacuum during a critical phase of the war. The loss of experienced leaders and the ensuing political instability weakened Athens in its struggle against Sparta and contributed to the eventual decline of its hegemony in the Greek world. The epidemic, therefore, was not merely a medical crisis, it altered the trajectory of one of history's most influential civilizations. From a scientific perspective, the plague of Athens demonstrates the vulnerability of human societies to infectious diseases even in the ancient world. Urban density, trade, and military activity provided the ideal conditions for rapid pathogen transmission. Ships, soldiers, and marketplaces acted as conduits for infection, similar to modern epidemics. Athens, a city that had flourished through connectivity and innovation, became a perfect storm for disease, a pattern that would repeat throughout human history whenever human mobility and density intersected with novel pathogens. The psychological and cultural ramifications of the plague are equally noteworthy. Thucydides observed widespread despair and a sense of fatalism. People no longer feared divine punishment or social reproach, as death seemed arbitrary and unavoidable. The epidemic forced a confrontation with mortality in a direct and immediate way, influencing philosophy, literature, and collective memory. Some historians argue that the psychological trauma contributed to shifts in Greek thought, including a more secular and empirical approach to understanding human events. A subtle, yet profound cultural impact born from a medical crisis. Interestingly, the plague of Athens also offers early lessons in public health, albeit unintentional ones. Quarantine and isolation, now standard practices in disease control, were rudimentary but evident. Thucydides notes that some people fled the city to avoid infection, while others avoided contact with the sick. Though knowledge of germ theory was millennia away, human instinct recognized that proximity facilitated transmission. Social behavior, even without scientific understanding, became a critical factor in survival. The epidemic also highlights the interplay between war and disease. The siege of Athens, which confined large populations within city walls and disrupted sanitation and food supplies, created conditions conducive to the spread of pathogens. History repeatedly demonstrates this connection. Armies, crowded cities, and logistical strain often amplify the impact of disease. The plague of Athens serves as one of the earliest documented examples of how conflict and infection can combine to magnify human suffering. Despite the tragedy, the plague of Athens did not annihilate the city completely. Surviving populations eventually rebuilt, adapted, and continued their cultural and intellectual contributions. Yet the memory of the epidemic persisted, influencing subsequent Greek thought and literature. It stands as an enduring reminder of the delicate balance between human civilization and the microscopic forces that can disrupt it. From a modern perspective, the plague of Athens offers critical insights into disease dynamics. It underscores the importance of urban planning, sanitation, and population density in controlling outbreaks. It illustrates the profound social and psychological consequences of widespread illness, and it reminds us that pathogens are not merely biological phenomena, they are historical agents capable of shaping politics, culture, and human destiny. In sum, the plague of Athens was more than an ancient medical event. It was a societal shockwave, a test of human resilience, and an early chapter in the long history of pandemics. By examining its causes, effects, and legacy, we gain a clearer understanding of how diseases interact with human civilization and how the lessons of the past continue to resonate in a world still vulnerable to new and emerging pathogens. This event, though over 2 millennia old, remains deeply relevant, providing both a historical case study and a mirror reflecting the ongoing struggle between humanity and the invisible forces that shape our existence. In the annals of history, the Roman Empire is often remembered for its vast territories, military prowess, and architectural marvels. Yet even an empire built on discipline and strength could not escape the invisible threats that travel alongside human ambition. Between 165 and 180 CE, the Roman world faced a calamity now known as the Antonine Plague, a devastating epidemic that would shake the foundations of one of the most powerful civilizations the world had ever seen. The Antonine Plague, named after the ruling Antonine dynasty, arrived during a period of relative stability for Rome, coinciding with the reigns of emperors Marcus Aurelius and Lucius Verus. Historical accounts suggest that the plague was brought back to Rome by soldiers returning from campaigns in the Near East, highlighting the recurring theme: human mobility as a vehicle for disease transmission. The specific pathogen is still debated, but most modern scholars believe it was either smallpox or measles. Ancient texts, including the writings of Galen, describe fever, diarrhea, sore throat, pustules, and widespread mortality, symptoms consistent with these highly contagious viral diseases. Estimates of the death toll vary, but it is believed that the plague killed between 5 and 10 million people across the empire, including a significant portion of the Roman army. The disease's impact on military campaigns was profound. Rome's frontiers, already stretched thin by ongoing conflicts with Germanic tribes and Parthians, became vulnerable as entire legions were decimated. The loss of manpower disrupted the logistics of war, weakened defenses, and forced the empire to reconsider its strategic priorities. The Antonine Plague was, in effect, a biological weapon of unprecedented scale, delivered not by an enemy army, but by the microscopic organisms invisible to the naked eye. The social consequences of the Antonine Plague were equally severe. Urban centers, densely populated and reliant on trade and agriculture, experienced high mortality rates. Families were torn apart, labor shortages emerged, and the economy suffered significant disruption. Farmers abandoned fields, and trade routes slowed, creating ripple effects that reached even the furthest corners of the empire. In many ways, the plague exposed the vulnerabilities inherent in a highly connected society, revealing that the very structures that allowed Rome to flourish also facilitated the rapid spread of disease. From a cultural perspective, the Antonine plague influenced both philosophy and religion. Marcus Aurelius, renowned for his Stoic writings, personally witnessed the suffering and mortality around him. His meditations reflect an acute awareness of human fragility and the inevitability of death, likely shaped in part by the epidemic that claimed countless lives during his reign. The plague also prompted changes in religious practices as people sought divine explanations for the calamity, turning to new cults or reinforcing existing rituals in hopes of appeasing the gods. These societal responses illustrate a common pattern. In the absence of scientific understanding, human societies historically turned to spiritual frameworks to interpret and cope with disease. The Antonine plague also provides insight into the epidemiology of ancient diseases. The virus, or viruses, spread through population centers connected by trade and military campaigns, demonstrating the importance of mobility and human networks in the transmission of pathogens. Cities such as Rome, Alexandria, and Antioch, hubs of commerce and administration, became epicenters of infection. Quarantine measures were largely non existent, and medical treatments relied on rudimentary remedies, herbal medicines, and the intervention of physicians like Galen, whose observations remain invaluable to modern scholars. Galen noted the high mortality rate, the prolonged course of illness, and the patterns of transmission, laying early groundwork for epidemiological observation. The Antonine plague also had long-term demographic effects. High mortality, especially among young adults, may have contributed to labor shortages that influenced economic patterns for decades. Military recruitment was hampered, and some historians argue that the demographic stress weakened the empire's ability to respond to subsequent crises. This epidemic, therefore, was not only a medical disaster, but also a catalyst for structural changes that shaped Roman society for generations. From a scientific standpoint, studying the Antonine plague illuminates the evolution of pathogens over time. Ancient DNA analysis, while still limited, has begun to reveal the genetic signatures of historic smallpox strains, offering clues about how viruses evolve and spread. The Antonine plague serves as an early case study of zoonotic diseases, population vulnerability, and the interplay between human activity and pathogen dynamics, lessons that remain relevant in today's understanding of pandemics. The plague also emphasizes the role of human behavior in disease transmission. Soldiers, merchants, and travelers acted as vectors, inadvertently spreading the disease across continents. Urban density, sanitation challenges, and close quarters in military encampments exacerbated the spread. These factors mirror many of the dynamics seen in modern epidemics, highlighting the continuity of human vulnerability across millennia. Perhaps one of the most striking aspects of the Antonine plague is how it underscores the fragility of human confidence in the face of microscopic forces. The Roman Empire, often viewed as the epitome of organization and control, was humbled by a pathogen invisible to the eye, immune to the strategies of generals and the authority of emperors. The epidemic revealed that human ingenuity, for all its brilliance, has always existed alongside biological forces that can circumvent power, borders, and wealth. In summary, the Antonine Plague was a pivotal moment in the history of pandemics. It demonstrates the interconnectedness of human society, the impact of disease on military, economic, and cultural systems, and the enduring influence of pathogens on the trajectory of civilizations. By studying this epidemic, we gain insight not only into the vulnerabilities of the past, but also into patterns that continue to shape global health today. The plague reminds us that human ambition, technology, and power are always counterbalanced by the unseen world of pathogens, a lesson that echoes through every epidemic and pandemic in human history. By the mid 6th century, the Roman world had transformed into the Byzantine Empire, with Constantinople standing as a bustling metropolis at the crossroads of Europe and Asia. It was during this period, beginning in 541 CE, that the first historically documented outbreak of the bubonic plague emerged on a truly catastrophic scale, known as the Plague of Justinian, after the emperor who reigned during its initial outbreak. This pandemic would reverberate across continents, leaving profound demographic, economic, and political consequences in its wake. The Plague of Justinian is often regarded as the earliest recorded pandemic caused by Yersinia pestis, the bacterium responsible for bubonic plague. Originating in the Egyptian port city of Pelusium, it spread rapidly through the Mediterranean via trade routes, particularly by ship. Constantinople, a city of over 500,000 inhabitants, became the epicenter, ships arriving with cargo, food, and inadvertently, rats carrying infected fleas introduced the pathogen to the densely packed urban population. Within weeks, the disease ran rampant, exploiting the intimate living conditions, poor sanitation, and bustling marketplaces of the imperial capital. Contemporary accounts, particularly those of the historian Procopius, describe the harrowing effects of the plague. Victims exhibited high fevers, swelling of the lymph nodes, extreme fatigue, vomiting, and blackened skin lesions, a hallmark of bubonic plague. Mortality rates were staggering. Some estimates suggest that up to 50% of Constantinople's population perished during the first wave. Entire neighborhoods emptied as families succumbed. Streets were littered with corpses, and the city's infrastructure struggled to cope with the scale of the catastrophe. The social and psychological impact of the plague of Justinian was immense. Fear and panic permeated every stratum of society. Traditional religious and civic norms were strained as people grappled with the randomness of death. Burial practices became improvised, and public order was challenged as desperation overcame social cohesion. The epidemic also created profound economic disruptions. Labor shortages affected agriculture, artisanship, and trade, leading to higher prices and famine in some regions. The Byzantine Empire, despite its centralized administration and wealth, faced a crisis of governance as the plague weakened both military and civil institutions. From a political perspective, the plague of Justinian had far-reaching consequences. Emperor Justinian I, determined to continue his ambitious campaigns of reconquest across the former Western Roman territories, faced enormous obstacles. Armies weakened by mortality and recruitment difficulties struggled to maintain campaigns in Italy, North Africa, and Spain. The plague's demographic toll also undermined tax collection and urban productivity, placing a significant strain on the imperial treasury. Some historians argue that the long-term weakening of the empire contributed to the inability of Byzantium to resist later invasions, including those by Slavic and Arab forces. The plague of Justinian also illustrates the interplay between trade, urbanization, and disease. Constantinople's status as a commercial hub connecting Europe, Asia, and Africa facilitated the rapid spread of the plague across the Mediterranean world. Ports and caravans acted as vectors, carrying the bacterium to cities such as Alexandria, Antioch, and even as far as the Italian peninsula. The epidemic demonstrates the inherent risks of human connectivity, a pattern that echoes in every pandemic from the Antonine plague to the modern era of global travel. Scientific research into the plague of Justinian has advanced significantly in recent decades. Ancient DNA extracted from plague victims has confirmed the presence of Yersinia pestis, linking this pandemic to the same pathogen responsible for the infamous Black Death of the 14th century. Genomic studies have allowed researchers to trace the evolution of the bacterium, revealing how it adapted to different hosts and environments over centuries. These findings not only illuminate the past, but also enhance our understanding of how pathogens can persist, mutate, and reemerge over time. The epidemic also highlights the human responses to disease before modern medicine. Quarantine measures, though primitive, were sometimes employed. Individuals suspected of infection might be isolated, and trade restrictions were occasionally enforced. Physicians like Paul of Aegina recorded symptoms and attempted treatments, relying on a combination of herbal remedies, bloodletting, and observational strategies. While largely ineffective by modern standards, these efforts reflect early attempts at systematic medical intervention in the face of overwhelming mortality. One of the more profound lessons of the plague of Justinian is the way it reshaped societal structures. High mortality rates led to shifts in labor dynamics, land ownership, and urban life. Surviving populations often consolidated wealth or migrated to less affected regions, creating patterns of demographic and economic change that echoed for generations. The epidemic also reinforced the perception of human vulnerability to forces beyond control, influencing theology, philosophy, and cultural expression. The sense of divine judgment, fate, and mortality pervaded literature and religious thought, shaping the spiritual and intellectual climate of the Byzantine world. The recurrence of the plague over subsequent decades, with waves in 542, 544, and intermittently until the mid-8th century, demonstrates the persistence of pathogens in human populations. Unlike one-time epidemics, the plague of Justinian established a long-term, cyclical threat that shaped policy, urban planning, and public health practices. Lessons from this period underline the importance of understanding not just individual outbreaks, but the long-term ecological and societal dynamics that allow diseases to persist over centuries. From a broader historical perspective, the plague of Justinian bridges the gap between ancient and medieval pandemics. It serves as a precursor to the Black Death, providing a model for how bubonic plague interacts with human societies, infrastructure, and trade networks. Studying this pandemic allows historians, epidemiologists, and public health experts to trace patterns of contagion, mortality, and societal resilience across centuries, offering insights relevant even in the modern era of emerging infectious diseases. In conclusion, the plague of Justinian was more than a health crisis. It was a transformative event that reshaped the Byzantine Empire, influenced political and economic structures, and left an indelible mark on cultural and religious life. By examining the epidemiology, societal impact, and long-term consequences, we gain a clearer understanding of how early pandemics shaped human history. It reminds us that even the mightiest civilizations are vulnerable to microscopic forces, and that the interplay between humans, pathogens, and the environment has been a defining factor in the course of our species from ancient times to today. The 14th century stands as one of the most infamous periods in human history, defined not by conquest or kings, but by a single microscopic organism that brought the world to its knees. Known as the Black Death, this pandemic swept across Europe, Asia, and North Africa between 1347 and 1351, killing tens of millions and reshaping societies in ways that continue to resonate today. Unlike previous plagues, the Black Death's scale, speed, and mortality rates created a global shock that few events in history can match. The causative agent of the Black Death was the bacterium Yersinia pestis, carried primarily by fleas that infested black rats. The disease manifested in three primary forms: bubonic, pneumonic, and septicemic plague. Bubonic plague, the most common form, was characterized by swollen lymph nodes called buboes, fever, chills, and fatigue. Pneumonic plague attacked the lungs, allowing the disease to spread directly between humans via respiratory droplets, making it particularly deadly in crowded urban centers. Septicemic plague, although rarer, led to blood poisoning and almost certain death. The combination of these forms ensured that the Black Death was not only highly lethal, but also extraordinarily efficient at spreading across regions and populations. Thus, origins of the Black Death trace back to Central Asia, likely in regions around the Tian Shan Mountains, or along trade routes connecting China and the Mongol Empire. The disease traveled along the Silk Road, reaching Crimea and then the port cities of the Mediterranean through merchant ships. From these entry points, it spread rapidly across Europe, reaching as far north as Scandinavia and as far west as the Iberian Peninsula. Within just a few years, an estimated 30 to 60% of Europe's population had perished, with mortality rates varying between cities and regions. The scale of death was unprecedented. Entire villages disappeared, agricultural fields went untended, and trade networks collapsed under the weight of human loss. The social impact of the Black Death was profound and far-reaching. Families were decimated, leaving orphaned children and elderly survivors struggling to maintain households. Labor shortages emerged on an unprecedented scale, forcing economic shifts that altered wages, land use, and the balance of power between peasants and nobility. In some regions, these shortages led to social unrest, rebellions, and the questioning of feudal hierarchies. The demographic shock transformed European society, accelerating shifts in economic systems, labor practices, and urban development that would influence the trajectory of the Renaissance and beyond. Psychologically, the Black Death instilled profound fear and uncertainty. Medieval communities, lacking knowledge of germ theory or effective treatments, turned to religious and supernatural explanations. Some viewed the plague as divine punishment, prompting acts of penance, flagellation, and the persecution of marginalized groups such as Jews, who were falsely accused of poisoning wells. Art and literature from the period reflect this obsession with mortality. The Danse Macabre, a visual representation of death leading all humans to the grave, emerged as a powerful cultural motif, capturing the omnipresence of death in daily life. Literature, poetry, and chronicles from the period also describe the psychological toll of watching entire families, neighbors, and communities succumb to the disease within days. The Black Death also provides critical insights into epidemiology and public health. Urban density, poor sanitation, and the close coexistence of humans and rodents created ideal conditions for plague transmission. Merchants, pilgrims, and armies acted as vectors, facilitating the spread of the disease across vast distances. Cities attempted primitive containment strategies, including isolation of affected households, restrictions on movement, and even the burning of contaminated clothing and bedding. Though these measures were rudimentary, they reflect early recognition of transmission dynamics, a precursor to modern public health practices. From a scientific perspective, the Black Death represents a landmark in understanding pathogen evolution. Yersinia pestis demonstrates remarkable adaptability, evolving over centuries to survive in multiple hosts and vectors. Studies of ancient DNA extracted from plague victims have allowed researchers to reconstruct the genome of medieval strains, providing insight into virulence, transmission pathways, and evolutionary history. The Black Death also illustrates the interplay between environment, ecology, and disease, climate fluctuations, rodent populations, and human migration all contributed to the timing and intensity of outbreaks. The economic consequences of the Black Death were similarly transformative. With a dramatic reduction in the labor force, survivors often found their work in higher demand, enabling wages to rise and social mobility to increase in ways previously impossible under rigid feudal systems. Land that had been cultivated for generations was abandoned, while innovations in agriculture emerged to compensate for labor shortages. These shifts had long-term impacts, contributing to the decline of feudalism and the gradual emergence of more modern economic systems across Europe. In addition to social and economic transformations, the Black Death had profound cultural and intellectual implications. The omnipresence of mortality prompted philosophical reflection, theological debate, and advancements in medicine and hygiene. Scholars began to question traditional medical practices, observe patterns in disease spread, and seek empirical explanations for illness, laying early groundwork for epidemiology and public health. The plague also accelerated urban planning reforms, including improvements in water supply, waste management, and housing design, as cities sought to reduce vulnerability to future outbreaks. The Black Death also highlights the interconnectedness of human societies. Maritime trade, overland routes, and military campaigns facilitated the movement of pathogens across continents, demonstrating that no civilization was isolated from the threats posed by disease. This interconnectedness, while contributing to economic and cultural exchange, also magnified vulnerability, a dynamic still relevant in the modern era of global pandemics. In conclusion, the Black Death stands as one of the most consequential pandemics in human history. Its combination of lethality, speed, and social disruption transformed Europe, reshaping demographics, economies, culture, and even political structures. By examining the scientific, historical, and societal dimensions of this pandemic, we gain insight into the dynamics of infectious disease and the ways in which humanity has adapted to survive. The Black Death serves as a stark reminder that microscopic pathogens, though invisible, wield the power to reshape civilizations, leaving legacies that endure for centuries and continue to inform our understanding of pandemics today. The Black Death did not merely extinguish millions of lives across Europe, Asia, and North Africa. It fundamentally reshaped the societies that survived it. When the plague finally receded in the mid 14th century, humanity faced the daunting task of rebuilding from near collapse. Entire communities had been decimated, economies were disrupted, and social hierarchies were questioned in ways previously unimaginable. Yet from this devastation emerged profound transformation. Society, labor, culture, and governance were all reborn from the ashes, altered forever by the invisible hand of a microscopic pathogen. Demographically, the aftermath of the Black Death was staggering. Europe lost an estimated 60% of its population. Though regional variations existed, some cities, like Florence and Siena, saw mortality rates exceeding half of their inhabitants. Rural areas were not spared. Entire villages were wiped out, fields went fallow, and forests expanded into previously cultivated lands. This demographic shock created both challenges and opportunities. Labor became scarce, giving surviving peasants and workers newfound leverage in negotiating wages, rents, and working conditions. Serfs in many regions began to demand more freedom, contributing to the gradual erosion of the rigid feudal system that had dominated medieval Europe for centuries. Economically, the Black Death catalyzed profound shifts. Labor shortages forced landowners to compete for workers, leading to wage increases and improved living conditions for those who survived. This economic empowerment of the lower classes, while threatening to traditional elites, also incentivized innovation. Agricultural techniques evolved to compensate for fewer hands in the fields, including crop rotation, the use of draft animals, and improvements in plowing technology. In cities, artisan guilds and merchants benefited from reduced competition, enabling the expansion of trade, craft specialization, and early capitalist structures. In short, the devastation of the Black Death paradoxically accelerated economic modernization. Social structures also experienced a dramatic transformation. The rigid hierarchy of medieval society, once reinforced by a surplus of laborers beholden to lords, was destabilized. Peasant revolts, such as the English Peasants' Revolt of 1381, reflected the newfound assertiveness of the lower classes and the growing tension between labor and authority. Urban populations, less bound by feudal obligations, became hubs of cultural and economic experimentation. Cities like Florence, Venice, and Bruges began to flourish, laying the groundwork for the Renaissance. The Black Death, therefore, indirectly fueled a cultural and intellectual awakening as societies adjusted to the new demographic and economic realities imposed by the pandemic. The psychological impact of the Black Death was equally profound. The ubiquity of death and suffering created a pervasive sense of existential awareness. Art, literature, and philosophy of the period reflect this confrontation with mortality. The danse macabre, or dance of death, emerged as a visual representation of death's universality, depicting figures from kings to peasants, led by skeletal dancers to the grave. Writers like Giovanni Boccaccio in the Decameron captured both the horrors and human behaviors provoked by the epidemic. Fear, altruism, indulgence, and survival instinct. Religious thought was also affected. Some turned toward intense piety, while others questioned the church's authority, particularly as the clergy themselves were decimated and spiritual guidance proved insufficient to halt the spread of disease. Public health practices, rudimentary though they were, began to take root in response to the plague. Cities such as Venice and Milan instituted quarantine measures, isolating ships, merchants, and travelers suspected of carrying the disease. Burial protocols evolved, including mass graves and stricter handling of corpses in order to contain further spread. These early interventions laid the groundwork for more systematic approaches to epidemic control, demonstrating humanity's capacity to learn and adapt in the face of catastrophic health crises. The Black Death also left lasting impacts on culture and philosophy. Confronted with unprecedented mortality, thinkers and artists explored themes of impermanence, human vulnerability, and ethical responsibility. Literature, theater, and visual art became infused with an awareness of life's fragility, while religious institutions grappled with the need to address both spiritual and temporal crises. These cultural responses not only helped societies process trauma, but also fostered intellectual environments conducive to innovation, scientific inquiry, and philosophical reflection. Religious institutions, which had once wielded enormous power, faced challenges as clergy died in large numbers and faith alone could not protect against the disease. Some communities turned to mysticism, penance, or apocalyptic interpretations, while others sought to reform religious practice and make it more responsive to human needs. The weakening of unquestioned authority created space for social, political, and intellectual transformation, space that would eventually contribute to the rise of Renaissance humanism and secular thought. The Black Death also accelerated globalization in subtle ways. Trade routes reopened after initial disruptions, but with new awareness of the risks posed by human mobility, merchants, travelers, and urban centers developed more sophisticated mechanisms for trade, hygiene, and disease monitoring. The recognition that pathogens could move quickly across continents planted the seeds for a more interconnected and informed approach to commerce and communication, a precursor, in a sense, to the modern understanding of epidemiology and global health. From a demographic and epidemiological perspective, The Black Death reshaped Europe's population structure. With high mortality among children and young adults, societies faced generational gaps that influenced family structures, inheritance laws, and social dynamics. Populations slowly recovered over decades, but the distribution of wealth, land, and labor had been fundamentally altered. This demographic shock, combined with shifts in economic power, helped to weaken feudal bonds and empower urban centers and merchant classes, transforming the trajectory of European history. In conclusion, the aftermath of the Black Death illustrates humanity's remarkable capacity to adapt, innovate, and transform in response to catastrophic challenges. While the pandemic wrought death, fear, and social disruption, it also created opportunities for economic reform, social mobility, cultural expression, and intellectual growth. Societies reborn from the ashes of the plague emerged stronger, more flexible, and more aware of the fragility of human existence. By studying this period, we gain insight not only into the devastating consequences of pandemics, but also into the resilience, creativity, and adaptability that define the human response to invisible enemies. The Black Death was both a profound tragedy and a catalyst for transformation, a dark crucible from which the modern world began to take shape. Few diseases have left as enduring and profound a mark on human history as smallpox, caused by the variola virus. Smallpox is a highly contagious and often deadly disease that has plagued humanity for thousands of years. Unlike short-lived epidemics, smallpox was a persistent scourge, shaping the development of societies, influencing the outcomes of wars, and playing a decisive role in the expansion and collapse of empires. The origins of smallpox are ancient, with evidence suggesting that it may have afflicted humans for at least 3,000 years. Egyptian mummies dating back to the 3rd century BCE show lesions consistent with the disease, indicating that smallpox was already entrenched in human populations. The disease's high mortality rate, coupled with its capacity to spread rapidly through dense communities, made it a formidable adversary. It was not simply a health crisis, it became a social, economic, and political phenomenon wherever it appeared. Smallpox spreads primarily through respiratory droplets and direct contact with bodily fluids. Once infected, individuals develop high fevers, severe fatigue, and a characteristic rash that eventually forms pustules. Mortality rates varied between 20% and 40%, and survivors were often left with permanent scarring and, in some cases, blindness. The virus's combination of high transmissibility, lethality, and lasting effects made it uniquely devastating in pre-modern societies where medical knowledge and public health interventions were limited. The impact of smallpox on human history is staggering. In Europe, repeated outbreaks shaped urban planning, social behavior, and medical practice. During the Renaissance, major cities such as London, Paris, and Venice faced periodic epidemics that could decimate populations in weeks. Governments and communities developed rudimentary quarantine practices, isolation hospitals, and inoculation rituals, reflecting early attempts to manage the disease's relentless spread. Physicians documented symptoms, tracked outbreaks, and experimented with treatments, laying the groundwork for the eventual development of vaccination centuries later. Smallpox played an even more decisive role in the context of empire and conquest. When European colonizers arrived in the Americas, they inadvertently introduced the virus to indigenous populations who had no prior exposure and therefore no immunity. The consequences were catastrophic. Estimates suggest that smallpox, along with other diseases, wiped out as much as 90% of the indigenous population in some regions. Entire civilizations, including the Aztec and Inca empires, were destabilized, facilitating conquest and colonization. In this sense, smallpox was not only a medical phenomenon, but also a geopolitical force, profoundly influencing the balance of power between societies and nations. The history of smallpox also underscores the interplay between human innovation and disease. Variolation, an early form of inoculation practiced in Asia and Africa, involved exposing individuals to material from smallpox pustules to induce a milder infection and confer immunity. Though risky, this technique demonstrated a growing understanding of immunity and disease prevention. European physicians adopted and adapted these methods in the 17th and 18th centuries, laying the foundation for the development of Edward Jenner's groundbreaking smallpox vaccine in 1796. Jenner's innovation marked the beginning of a new era, transforming smallpox from a persistent scourge into the first disease to be eradicated by human intervention. The social consequences of smallpox were profound. Families were torn apart, communities were destabilized, and populations were periodically reduced to fractions of their original size. In addition to mortality, survivors faced long-term physical and psychological effects, including disfigurement and trauma. Religious interpretations often framed the disease as divine punishment, influencing ritual practices, moral codes, and collective behavior. In some cases, smallpox outbreaks led to the persecution of scapegoated groups, reflecting the deep fear and social disruption wrought by the virus. Economically, smallpox outbreaks disrupted trade, agriculture, and urban life. Labor shortages caused by mortality affected production and commerce, while fear of contagion discouraged travel and trade. Cities and towns implemented containment strategies, including cordons sanitaires and isolation of affected households. But these measures were often reactive rather than preventive. Despite these challenges, human societies gradually adapted, developing both cultural and medical strategies to cope with recurring outbreaks. Smallpox also demonstrates the long-term evolutionary interplay between humans and pathogens. Unlike some diseases, which burn out rapidly, smallpox persisted for centuries, evolving alongside human populations. Its high mortality rate was balanced by its ability to confer immunity in survivors, creating a dynamic equilibrium that allowed the virus to remain endemic in many regions. The historical persistence of smallpox illustrates the remarkable adaptability of pathogens and the ongoing arms race between disease and human innovation. Globally, smallpox's influence was enormous. In Africa, Asia, Europe, and the Americas, the disease shaped population patterns, migration, and the trajectory of civilizations. It influenced military campaigns as armies were vulnerable to outbreaks during sieges or long campaigns. Political leaders, aware of the threat, often took extraordinary measures to protect themselves and their populations, including isolation, travel restrictions, and medical interventions. Smallpox's ubiquity made it a central concern for rulers, physicians, and ordinary people alike. The eradication of smallpox in the 20th century represents one of humanity's greatest achievements. Following decades of vaccination campaigns coordinated by the World Health Organization, the last naturally occurring case was recorded in Somalia in 1977. Smallpox remains the only human disease to have been fully eradicated, a testament to scientific ingenuity, global cooperation, and the enduring human desire to conquer one of history's deadliest pathogens. Its eradication also offers lessons for the control of other infectious diseases, illustrating the importance of vaccination, public health infrastructure, and international collaboration. In conclusion, smallpox was far more than a disease. It was a transformative force that shaped empires, influenced cultural practices, and drove scientific innovation. Its persistent presence across centuries affected demography, politics, economics, and social structures. The story of smallpox is a testament to the profound impact that a microscopic pathogen can have on human history, demonstrating both the vulnerability of civilizations and the capacity of humans to adapt, innovate, and ultimately overcome even the deadliest of adversaries. Understanding smallpox provides a lens through which we can appreciate the complex interplay between disease, society, and human ingenuity, a pattern that continues to define our relationship with pandemics today. While pandemics, such as the Black Death and smallpox, captured the dramatic attention of history, humanity has also lived alongside a host of recurring, persistent diseases that quietly shaped societies over centuries. Measles, influenza, and scarlet fever may not always dominate headlines in the same way as bubonic plague, but their impact on human populations, health systems, and societal development has been profound. These diseases demonstrate the enduring interplay between pathogens and human communities, influencing everything from public health practices to cultural attitudes toward illness. Measles is one of the most contagious viral diseases known to humans, caused by the measles virus, a member of the paramyxovirus family. Its origins likely date back thousands of years, emerging as humans transitioned from small nomadic groups to large agricultural settlements, providing sufficient population density to sustain continuous viral transmission. The disease spreads via respiratory droplets, and a single infected individual can transmit the virus to 90% of susceptible contacts. Symptoms include high fever, cough, runny nose, red eyes, and the hallmark rash, which spreads across the body in distinct stages. Complications such as pneumonia, encephalitis, and death were common, particularly in populations lacking immunity or adequate nutrition. Historically, measles had a profound effect on societies, especially when it spread into previously isolated communities. Indigenous populations in the Americas, Australia, and the Pacific were particularly vulnerable after contact with Europeans, as these communities had no prior exposure or immunity. In the Americas, measles outbreaks decimated indigenous populations in conjunction with smallpox and influenza, contributing to social collapse and the destabilization of civilizations. In Europe, periodic epidemics of measles affected children and young adults, influencing family structures, schooling, and healthcare practices, while pushing physicians to study contagion and disease management more systematically. Influenza, another viral companion of humanity, demonstrates remarkable adaptability and global reach. Influenza viruses, members of the Orthomyxoviridae family, cause seasonal outbreaks as well as sporadic pandemics, often originating from interactions between humans, birds, and swine. Symptoms typically include fever, fatigue, sore throat, and respiratory distress. Its history is marked by both seasonal cycles and devastating pandemics, such as the Spanish flu of 1918 to 1919, which killed tens of millions worldwide. The virus's ability to mutate rapidly through antigenic drift and shift allows it to evade immunity, creating a constant challenge for populations and healthcare systems. Even in pre-modern times, influenza shaped communities by causing temporary labor shortages, disrupting trade, and prompting the development of early medical interventions, including isolation and supportive care. Scarlet fever, caused by the bacterium Streptococcus pyogenes, presents a different set of challenges, characterized by fever, sore throat, and a distinctive red rash. Scarlet fever was particularly deadly among children prior to the discovery of antibiotics. Historical records suggest that scarlet fever epidemics were common in Europe during the 17th to 19th centuries, often spreading rapidly in urban centers and boarding schools, while mortality rates were lower than those of smallpox or plague. The disease left significant morbidity, sometimes resulting in rheumatic fever, heart damage, or chronic complications. Its recurring presence influenced public health practices, hygiene standards, and the development of pediatric medicine, highlighting the persistent impact of endemic diseases on human populations. The societal effects of these persistent diseases were multifaceted. They influenced demographics, shaped cultural norms, and drove medical innovation. Families adjusted social practices to protect children. Communities developed early forms of quarantine and isolation, and physicians gradually refined methods of diagnosis and treatment. The recurring nature of measles, influenza, and scarlet fever fostered an evolving awareness of contagion and immunity, paving the way for the scientific breakthroughs that would eventually allow for vaccines and antibiotics. Culturally, these diseases left subtle but lasting marks. Measles, often considered a rite of passage in pre-vaccine societies, became embedded in collective memory through folklore, nursery rhymes, and parental guidance. Influenza outbreaks inspired both fear and adaptation, influencing travel, public gatherings, and medical practice. Scarlet fever, with its striking rash and prevalence among children, prompted community-level responses such as school closures and improved sanitation practices. Together, these diseases helped shape social attitudes toward health, hygiene, and communal responsibility. Scientific understanding of these diseases advanced gradually over centuries. Measles and influenza provided early insights into viral contagion, immunity, and the dynamics of epidemic spread. Scarlet fever offered a window into bacterial infections, the role of secondary complications, and the need for targeted medical interventions. The study of these pathogens contributed to the development of modern epidemiology, immunology, and public health infrastructure, illustrating how recurring diseases, though less dramatic than pandemics, like the plague, profoundly influenced scientific progress. The ecological and evolutionary aspects of these diseases are also noteworthy. Measles requires large populations to maintain transmission, highlighting the relationship between human settlement patterns and disease sustainability. Influenza demonstrates the importance of zoonotic transmission and viral mutation, emphasizing the ongoing threat of emerging strains. Scarlet fever, while bacterial, reflects how pathogens exploit social environments, particularly among children in dense communities. Together, these diseases underscore the continuous interaction between human behavior, ecology, and pathogen evolution. From a modern perspective, measles, influenza, and scarlet fever offer enduring lessons in prevention and public health. Vaccination, hygiene, isolation, and surveillance remain central strategies in controlling these diseases. Their historical impact demonstrates how persistent pathogens shape societies, not only through mortality, but also through cultural adaptation, scientific inquiry, and policy development. Understanding these diseases provides a broader view of the long-term relationship between humans and infectious agents, a relationship characterized by challenge, adaptation, and innovation. In conclusion, measles, influenza, and scarlet fever exemplify the persistent, pervasive influence of infectious diseases on human history. Though they often operated quietly in the background compared to catastrophic pandemics, their recurring presence shaped societies, cultures, and scientific thought. By studying these diseases, we gain insight into how human populations respond to continuous health threats, how pathogens evolve alongside us, and how societies innovate to survive and thrive in the face of recurring biological challenges. These persistent companions remind us that disease is not only an episodic catastrophe, but also an enduring partner in humanity's journey through history. Cholera, caused by the bacterium Vibrio cholerae, is one of history's most notorious waterborne diseases. Unlike airborne pathogens, such as influenza or smallpox, cholera spreads through contaminated water and food, linking human survival directly to sanitation, hygiene, and public infrastructure. Its history demonstrates how environmental conditions, urbanization, and social practices can combine to magnify the impact of a microscopic organism, creating epidemics that disrupt societies, economies, and political systems. The first recorded cholera pandemics occurred in the early 19th century, although localized outbreaks had existed for centuries in the Indian subcontinent. Bengal, with its dense population and extensive river systems, provided ideal conditions for the bacterium to persist and spread. The disease is transmitted primarily through ingestion of water or food contaminated with Vibrio cholerae, often from human feces, making sanitation the critical factor in controlling outbreaks. Once infected, individuals experience acute diarrhea, vomiting, and severe dehydration. Without prompt treatment, death can occur within hours, making cholera one of the most frightening and fast-acting diseases in human history. The first global cholera pandemic, which began in 1817, spread from India through trade routes across Asia, reaching the Middle East, Europe, and eventually Africa. Over the next century, multiple pandemics would sweep across continents, devastating populations and shaping urban planning, public health policy, and medical science. Cholera's rapid spread, particularly in crowded cities with inadequate sanitation, highlighted the critical relationship between human infrastructure and disease control. Epidemics in London, Paris, and New York in the 19th century prompted the development of modern sewage systems, clean water supply networks, and public health institutions that form the backbone of urban resilience today. From a scientific perspective, cholera played a pivotal role in the development of epidemiology. The 1854 outbreak in London, famously investigated by physician John Snow, marked a turning point in understanding disease transmission. Snow traced cases to a contaminated water pump on Broad Street, demonstrating that cholera spread through water rather than miasma or bad air, the prevailing theory at the time. His meticulous mapping and observational studies laid the foundation for modern epidemiology, illustrating the power of empirical investigation in combating disease. Snow's work not only saved lives, but also transformed public health policy, leading to the systematic implementation of water treatment and sanitation measures. The societal impact of cholera epidemics was profound. High mortality rates, fear of contagion, and social disruption affected entire communities. In cities, panic often led to flight, abandonment of homes, and breakdowns in daily life. Economic activities slowed as trade and commerce were disrupted, and political authorities faced pressure to respond effectively or risk unrest. Cholera outbreaks also exposed social inequalities. The poor, living in unsanitary conditions, were disproportionately affected, while wealthier individuals often had access to cleaner water and better medical care. These disparities underscored the relationship between social infrastructure, public health, and societal resilience. Cholera also influenced medical science and public health beyond John Snow's pioneering work. The bacterium Vibrio cholerae was identified by Filippo Pacini in 1854, although his findings were initially overlooked. Later, Robert Koch isolated the pathogen in 1883, confirming the microbial cause of cholera. These discoveries reinforced the germ theory of disease, providing concrete evidence that microorganisms, not environmental miasma or divine punishment, were responsible for epidemics. Cholera thus catalyzed a broader scientific revolution, contributing to our understanding of microbiology, sanitation, and disease prevention. Culturally, cholera left its mark on literature, art, and social consciousness. The fear and unpredictability of outbreaks permeated urban life, influencing public perception of cleanliness, hygiene, and modernity. Cities like London, Paris, and Hamburg implemented not only infrastructural improvements, but also public awareness campaigns, demonstrating the evolving relationship between science, policy, and societal behavior. Epidemics of cholera were no longer merely medical crises, they became catalysts for civic organization, social reform, and technological innovation. Cholera's global reach illustrates the interplay between human movement and pathogen spread. Trade ships, military campaigns, and migration facilitated the rapid transmission of the bacterium across continents. Epidemics in Europe often coincided with periods of war, trade expansion, or urban crowding, demonstrating that societal factors directly influence the trajectory of disease. Cholera reminds us that pathogens exploit human behavior, infrastructure, and population density, making public health both a scientific and social endeavor. The disease also highlights the importance of prevention over treatment. While rehydration therapy and antibiotics can be effective, the greatest impact comes from clean water, proper sewage disposal, and hygiene education. The history of cholera illustrates a fundamental principle of epidemiology. Human societies can mitigate the effects of deadly pathogens through infrastructure, planning, and behavioral change, long before vaccines or cures exist. In this sense, cholera catalyzed modern public health thinking, emphasizing proactive measures and collective responsibility. In conclusion, cholera is more than a historical epidemic. It is a case study in the relationship between environment, infrastructure, and human health. Its impact over the past 2 centuries demonstrates how pathogens exploit societal vulnerabilities, while also highlighting humanity's capacity to innovate, adapt, and implement systemic solutions. Cholera shaped cities, policies, science, and public awareness, leaving a legacy that continues to inform modern urban planning, sanitation, and disease control. The story of cholera reminds us that water, often taken for granted, can be both life-giving and deadly, and that the microscopic world constantly intersects with human civilization in profound ways. In the closing months of World War I, the world faced a deadly adversary far smaller than any soldier, the influenza virus, known today as the 1918 influenza pandemic or the Spanish flu. This viral outbreak became one of the deadliest events in human history, infecting an estimated one-third of the global population and claiming the lives of at least 50 million people worldwide. Unlike previous pandemics, the 1918 flu's virulence, rapid transmission, and global reach were amplified by modern transportation, dense troop movements, and urbanization, making it a defining moment in the history of infectious disease. The influenza virus responsible for the pandemic was an H1N1 strain, notable for its ability to spread rapidly and induce severe immune responses. Symptoms included sudden fever, fatigue, headaches, body aches, and respiratory distress. In many cases, the virus led to viral pneumonia or secondary bacterial infections, resulting in rapid deterioration and death within days. What made the 1918 pandemic particularly devastating was its unusual mortality pattern. Unlike typical influenza, which primarily affects the very young and the elderly, this strain disproportionately killed healthy young adults between the ages of 20 and 40. The reason is believed to be an overreaction of the immune system, known as a cytokine storm, which caused the body to attack itself in response to the virus. The pandemic emerged in the spring of 1918, with early outbreaks reported among soldiers in military camps in the United States and Europe. Troop movements during World War I facilitated the rapid spread of the virus across continents as soldiers carried the infection from training camps to battlefields and then back to their home countries. Crowded conditions in trenches, military hospitals, and urban centers created perfect conditions for transmission. By the autumn of 1918, the influenza virus had reached nearly every corner of the globe, from the Arctic to the Pacific Islands, demonstrating the unprecedented global connectivity of the modern world. The societal impact of the 1918 influenza pandemic was profound. Hospitals were overwhelmed, and medical personnel were often themselves victims of the disease. Public gatherings were restricted, schools and theaters closed, and daily life was disrupted on a scale comparable to wartime conditions. Governments, already strained by the demands of war, struggled to respond effectively. In many regions, public health messaging was inconsistent, sometimes suppressed due to concerns about morale during the war, which contributed to misinformation and confusion. Communities experienced not only high mortality, but also social disruption, fear, and grief on a massive scale. Economically, the pandemic caused significant disruption. Labor shortages affected agriculture, manufacturing, and services, while transportation systems were slowed or halted by illness among workers. The combined effects of war and disease created a global economic shock, demonstrating the vulnerability of human systems to infectious disease. Insurance claims, medical costs, and productivity losses were unprecedented, highlighting the pandemic's multifaceted impact on society beyond the immediate health crisis. Scientific understanding of influenza was still in its infancy in 1918. The viral nature of the disease was not yet known, and there were no vaccines or antiviral treatments. Physicians relied on supportive care, quarantine measures, and basic hygiene to limit transmission. The pandemic spurred research into virology and epidemiology, eventually leading to the isolation of the influenza virus in the 1930s and the development of vaccines. Lessons learned from the 1918 pandemic continue to inform modern public health strategies. Pandemic preparedness and influenza control measures. The psychological effects of the pandemic were also profound. Families lost multiple members in quick succession. Communities mourned en masse, and fear permeated daily life. Literature, journalism, and personal accounts from the period describe the pervasive anxiety and helplessness experienced by populations worldwide. The pandemic revealed the fragility of human life in an interconnected world and the limits of medical knowledge at the time. Yet it also demonstrated the resilience of communities as citizens adapted to social restrictions, developed improvised care systems, and supported one another through unimaginable loss. From a global perspective, the 1918 influenza pandemic underscores the interplay between human behavior, environment, and pathogen evolution. Military mobilization, urban crowding, and international trade accelerated transmission, while the virus's biological characteristics, rapid replication, high contagiousness, and atypical age-specific mortality amplified its impact. The pandemic highlighted the importance of monitoring disease outbreaks, understanding epidemiological patterns, and implementing coordinated public health interventions to mitigate global health crises. Culturally, the pandemic left a lasting imprint. Literature, art, and music reflected the pervasive sense of mortality and uncertainty. Families and communities developed new rituals for mourning and coping, while governments and medical institutions gradually formalized responses to epidemics. The 1918 influenza pandemic also shaped public consciousness about the importance of hygiene, vaccination, and epidemiology, laying the groundwork for modern approaches to infectious disease control. In conclusion, the 1918 influenza pandemic was a defining event in the history of humanity and disease. Its unprecedented mortality, rapid global spread, and social disruption revealed both the vulnerabilities of modern societies and the potential for resilience and innovation in the face of catastrophe. By studying the pandemic's history, science, and societal impact, we gain critical insight into the dynamics of infectious disease, the importance of public health infrastructure, and the ways in which human behavior and biology interact to shape the course of epidemics. The 1918 flu serves as a stark reminder that microscopic organisms, though invisible, can alter the trajectory of nations, societies, and lives, leaving lessons that remain vital for modern public health and pandemic preparedness. Poliomyelitis, commonly known as polio, is a viral disease that left an indelible mark on the 20th century. Unlike many infectious diseases that primarily cause fever or rash, polio is notorious for its ability to attack the nervous system, causing paralysis and sometimes death. The virus is highly contagious, spreading primarily through the fecal-oral route, often via contaminated water, food, or surfaces. Polio's impact was not just medical, it reshaped societies, spurred scientific innovation, and ultimately demonstrated humanity's capacity to conquer a once feared epidemic. The history of polio extends back centuries, with evidence of polio-like symptoms recorded in ancient Egyptian carvings and texts. However, epidemics did not occur regularly until the late 19th and early 20th centuries, coinciding with increasing urbanization and improved sanitation. Ironically, better sanitation delayed early exposure to the virus, reducing immunity in children and creating conditions for large-scale outbreaks. Cities in Europe and North America experienced devastating epidemics during the early 1900s, with thousands of children contracting the disease each year. In severe cases, polio caused permanent paralysis, usually of the legs, and sometimes affected muscles critical for breathing, requiring iron lungs and extensive care. The epidemiology of polio revealed key insights into disease transmission and prevention. The virus spreads silently. Many infected individuals exhibit mild or no symptoms, but remain capable of transmitting the pathogen to others. This characteristic made containment difficult, as asymptomatic carriers could unknowingly spark outbreaks. Schools, summer camps, and densely populated urban centers became hotspots for transmission. Communities responded with temporary closures, hygiene campaigns, and public awareness programs, reflecting an evolving understanding of epidemic management. Polio's societal impact was profound, particularly on children and families. The fear of paralysis permeated daily life, affecting play, schooling, and public activities. Parents vigilantly monitored hygiene, isolated sick children, and sometimes relocated to avoid infection. The disease's unpredictability and severity created widespread anxiety, and hospitals were often overwhelmed with patients needing long-term care. Polio also left lasting psychological effects on survivors, many of whom adapted to permanent disability while confronting social stigma and physical limitations. Scientific innovation accelerated in response to polio's threat. Jonas Salk's development of the first effective polio vaccine in 1955 marked a turning point, offering protection through inactivated virus inoculation. Shortly thereafter, Albert Sabin developed an oral polio vaccine, which proved easier to administer and facilitated mass immunization campaigns. These breakthroughs transformed public health strategies, demonstrating the potential of vaccination to control and eventually eradicate a once feared disease. Polio became a symbol of the power of science and global cooperation in the fight against infectious diseases. Polio also influenced social policy and infrastructure. In many countries, the disease prompted improvements in sanitation, clean water access, and healthcare systems. Rehabilitation centers, physiotherapy programs, and assistive technologies were developed to support survivors, reflecting broader societal commitments to care for those affected by infectious diseases. Public health campaigns emphasized hygiene, vaccination, and disease monitoring, laying the foundation for modern approaches to epidemic preparedness. The global impact of polio demonstrates the interplay between human behavior, public health, and pathogen dynamics. Outbreaks were influenced not only by viral biology, but also by patterns of urbanization, travel, and sanitation. Regions with limited access to clean water or healthcare experienced higher rates of transmission, highlighting disparities in vulnerability and the critical role of infrastructure in disease prevention. The worldwide eradication effort, led by the World Health Organization and partners, underscores the capacity of coordinated global action to confront persistent pathogens. Culturally, polio left an enduring legacy. Public figures, such as President Franklin D. Roosevelt, who was paralyzed by the disease, helped raise awareness, reduce stigma, and mobilize resources for research and care. Polio campaigns also promoted civic responsibility, emphasizing community participation in vaccination and public health initiatives. The disease's presence in the collective consciousness influenced media, education, and policy, shaping how societies perceive and respond to health threats. From an evolutionary perspective, polio illustrates the adaptability and persistence of viruses. Its ability to spread silently, infect multiple hosts, and cause varying levels of disease severity allowed it to persist in human populations for decades. The successful development of vaccines demonstrates that while pathogens evolve rapidly, human innovation and coordination can counter even highly adaptable viruses, providing a roadmap for tackling other infectious threats. In conclusion, polio represents a defining chapter in the history of infectious diseases. Its combination of fear, paralysis, and social disruption transformed societies, stimulated scientific breakthroughs, and inspired global public health initiatives. Studying polio offers insights into the interplay of biology, society, and technology in shaping human responses to disease. The story of polio is one of challenge, adaptation, and triumph, a testament to human ingenuity, resilience, and the enduring quest to overcome even the most formidable microscopic adversaries. Through vaccination, education, and international cooperation, humanity has moved from fear and paralysis to hope and eventual eradication, demonstrating that even the most persistent diseases can be defeated. As the 20th century drew to a close, humanity confronted a new kind of pandemic, one that challenged not only medical science, but also social norms, politics, and global cooperation. HIV/AIDS, caused by the human immunodeficiency virus, HIV, emerged as a devastating and enduring epidemic that has shaped modern society in profound ways. Unlike historical pandemics, with sudden, visible symptoms like plague or smallpox, HIV/AIDS is a slow moving virus, attacking the immune system and creating vulnerability to opportunistic infections, making it both insidious and deadly. HIV is believed to have crossed into humans from non human primates in Central and West Africa during the early 20th century, although it was first recognized clinically in the early 1980s. The virus spreads primarily through the exchange of bodily fluids, including blood, semen, and breast milk, and can be transmitted sexually, perinatally, or through contaminated needles. Unlike many infectious diseases, HIV does not cause immediate illness. Instead, it progressively weakens the immune system over years, culminating in acquired immunodeficiency syndrome, AIDS, which leaves individuals susceptible to life-threatening infections and cancers. The global spread of HIV/AIDS is a story of both biology and human behavior. Urbanization, migration, and international travel facilitated its dissemination across continents. By the mid-1980s, HIV/AIDS had reached North America, Europe, Asia, and Latin America, exposing gaps in public health infrastructure, societal awareness, and medical knowledge. Early misconceptions, stigma, and fear fueled discrimination, marginalization, and social upheaval. Populations most affected, including men who have sex with men, intravenous drug users, sex workers, and communities in sub-Saharan Africa, faced not only the disease but also widespread prejudice, complicating efforts to provide care and prevention. The scientific response to HIV/AIDS evolved rapidly, driven by urgency and innovation. Researchers identified the virus in 1983, developed diagnostic tests, and began investigating antiretroviral therapies, ART, to control viral replication. ART, introduced in the mid-1990s, transformed HIV from a death sentence into a manageable chronic condition, significantly reducing mortality and improving quality of life. Medical breakthroughs included the development of pre-exposure prophylaxis, PrEP, mother-to-child transmission prevention, and strategies for global distribution of life-saving medications. HIV/AIDS thus became a catalyst for biomedical innovation, accelerating vaccine research, epidemiology, and public health policy. Societally, HIV/AIDS forced a reckoning with public attitudes toward health, sexuality, and responsibility. Governments, NGOs, and communities launched educational campaigns emphasizing safe practices, testing, and awareness. Activism by organizations such as ACT-UP highlighted systemic inequalities in healthcare access, challenged stigmatization, and demanded equitable treatment and funding. These efforts reshaped global health governance, fostering international collaboration and emphasizing human rights as central to public health strategies. Economically, the pandemic had profound implications in regions such as sub-Saharan Africa. High prevalence of HIV or AIDS reduced labor productivity, strained healthcare systems, and affected economic growth. The costs of medical care, social support, and loss of skilled workers were staggering, underscoring the interconnectedness of health and economic stability. Global initiatives, including the President's Emergency Plan for AIDS Relief, PEPFAR, and programs coordinated by the World Health Organization, addressed these challenges by funding treatment, prevention, and education campaigns, illustrating the necessity of coordinated international response to pandemics. The cultural impact of HIV/AIDS was equally significant. The pandemic influenced literature, film, music, and art, creating a space for public discussion of previously taboo topics, including sexuality, identity, and mortality. It reshaped public health communication, emphasizing transparency, empathy, and community involvement. The pandemic also sparked new approaches to epidemiology, behavioral science, and health communication, integrating social understanding into scientific response. HIV/AIDS highlights the complexity of modern pandemics. Unlike acute diseases, its slow progression and asymptomatic periods complicate detection and containment. Its spread is intertwined with social behavior, inequality, and infrastructure, demonstrating that disease is not solely a biological phenomenon, but a socio-ecological one. The pandemic underscores the importance of surveillance, community engagement, education, and access to healthcare in controlling global health threats. From a scientific perspective, HIV/AIDS has provided unparalleled insights into virology, immunology, and vaccine development. Research into the virus's life cycle, immune evasion strategies, and mutation patterns has informed understanding of other pathogens, including coronaviruses and emerging infectious diseases. HIV's persistence highlights the ongoing evolutionary arms race between humans and pathogens, illustrating how viral adaptability can challenge even the most advanced medical systems. In conclusion, HIV/AIDS is one of the defining pandemics of the modern era, reshaping medicine, society, and global health governance. It revealed vulnerabilities in healthcare systems, exposed social inequities, and inspired activism, innovation, and international collaboration. Studying HIV/AIDS provides essential lessons about the interplay between biology, behavior, and society in shaping disease outcomes. It reminds us that modern pandemics are not only scientific challenges, but also social and cultural phenomena that demand comprehensive, humane, and coordinated responses. HIV/AIDS transformed our understanding of epidemics and left a lasting legacy, demonstrating that even in the face of persistent, invisible threats, human resilience, ingenuity, and solidarity can prevail. In the early 21st century, humanity faced a new class of viral threats, coronaviruses. While known to science for decades as causes of mild respiratory illness, several coronaviruses emerged as deadly pathogens, revealing the ongoing vulnerability of global populations to novel infectious diseases. Severe acute respiratory syndrome, SARS, Middle East respiratory syndrome, MERS, and more recently, COVID-19, have demonstrated that in an interconnected world, microscopic pathogens can spread rapidly, challenge public health systems, and reshape societies on a global scale. The story begins with SARS, first identified in 2002 in Guangdong Province, China, caused by SARS-CoV. This coronavirus jumped from animals to humans, likely originating in bats and passing through civet cats. The virus spread via respiratory droplets, causing fever, cough, and severe pneumonia in infected individuals. With a case fatality rate of approximately 10%, SARS sparked global concern despite infecting only about 8,000 people. Rapid identification, isolation, and international cooperation allowed the outbreak to be contained within months, demonstrating the potential for coordinated public health response to emerging pathogens. The SARS outbreak underscored the importance of surveillance, transparency, and global collaboration in disease control. Just over a decade later, MERS emerged in Saudi Arabia in 2012, caused by MERS-CoV. Like SARS, the virus is believed to have originated in bats, with dromedary camels acting as an intermediary host. MERS primarily spreads through close contact, particularly in healthcare settings, and causes severe respiratory illness with a case fatality rate around 35%. While it did not reach the pandemic scale of SARS or COVID-19, MERS highlighted vulnerabilities in hospital infection control, the risks of zoonotic spillover, and the need for rapid diagnostic and containment strategies. Both SARS and MERS served as warnings of the potential for novel coronaviruses to cross species barriers and exploit global connectivity. Coronaviruses are RNA viruses capable of rapid mutation and adaptation. Their ability to recombine in animal hosts facilitates the emergence of new strains, making them unpredictable and dangerous. SARS and MERS revealed that human interaction with wildlife through markets, domestication, and habitat encroachment creates opportunities for zoonotic transmission. These outbreaks prompted a re-evaluation of human-animal interfaces, biosecurity measures, and surveillance programs, emphasizing the role of ecological understanding in pandemic prevention. The societal impact of SARS and MERS extended beyond immediate illness and mortality. Fear and uncertainty disrupted travel, commerce, and daily life. Quarantines, travel advisories, and hospital closures were implemented in affected regions, while public awareness campaigns sought to reduce panic and encourage protective behaviors. Economies, particularly those dependent on tourism and international trade, experienced short-term shocks, highlighting the interconnectedness of global health and economic stability. Public health responses to these coronavirus outbreaks catalyzed scientific innovation. Diagnostic tests were rapidly developed, epidemiological models refined, and international networks for data sharing established. Hospitals strengthened infection control protocols. Personal protective equipment became standardized, and early warning systems for emerging diseases were expanded. SARS and MERS provided invaluable experience that shaped preparedness strategies for future pandemics, emphasizing speed, transparency, and evidence-based interventions. Culturally, these outbreaks influenced social behavior and collective consciousness. Public health messaging emphasized hygiene, mask wearing, and social responsibility, laying the foundation for behavioral changes that would become critical during the COVID-19 pandemic. Media coverage, public discourse, and governmental communication highlighted the importance of trust, accurate information, and international cooperation in mitigating fear and fostering compliance with health measures. The coronavirus family illustrates the ongoing challenge of emerging pathogens. Their evolutionary dynamics coupled with human activities such as urbanization, deforestation, and global travel, increase the likelihood of spillover events. SARS and MERS serve as case studies in rapid identification, containment, and global cooperation, demonstrating both the vulnerabilities and capabilities of modern public health systems. They also reveal the importance of investment in virology research, surveillance, and pandemic preparedness before crises emerge. The lessons from SARS and MERS became tragically relevant with the arrival of COVID-19 caused by SARS-CoV-2. Unlike its predecessors, COVID-19 achieved unprecedented global spread, facilitated by asymptomatic transmission, high human mobility, and delayed initial recognition. The pandemic caused millions of deaths, disrupted societies worldwide, and reshaped economies, governance, and daily life. The experiences of SARS and MERS informed responses, highlighting the need for rapid testing, contact tracing, social distancing, vaccination, and global collaboration. In conclusion, SARS, MERS, and the broader coronavirus family represent a new era of global pandemics, one defined by rapid spread, zoonotic origins, and societal interconnectivity. These viruses reveal the delicate balance between humans, animals, and the environment, while underscoring the importance of science, public health infrastructure, and international cooperation. Studying these outbreaks provides essential lessons in vigilance, preparedness, and adaptability. Coronaviruses remind us that in a globally connected world, microscopic pathogens can have macro-level consequences, and that the strategies we develop today determine our ability to survive and thrive in the face of future pandemics. Ebola virus disease, a severe and often fatal hemorrhagic fever, represents one of the most terrifying modern infectious threats. Emerging from the remote rainforests of Central and West Africa, Ebola's outbreaks capture both the lethal efficiency of a pathogen and the vulnerabilities of human societies in the face of zoonotic disease. Unlike influenza or coronaviruses, Ebola is transmitted primarily through direct contact with bodily fluids of infected individuals, creating intense local outbreaks that can devastate communities in a matter of weeks. The first recognized outbreak of Ebola occurred in 1976, simultaneously in Nizara, Sudan, and Yambuku, Democratic Republic of Congo, then Zaire. The virus was named after the Ebola River, which flowed near one of the initial outbreak sites. Ebola belongs to the Filoviridae family, characterized by filamentous RNA viruses that can induce severe immune responses and multi-organ failure. Infected individuals experience sudden fever, fatigue, muscle pain, headache, and sore throat, followed by vomiting, diarrhea, rash, and in severe cases, hemorrhaging from mucous membranes. Mortality rates range from 25% to over 90%, depending on the viral strain, healthcare access, and response measures. Ebola's emergence is closely linked to zoonotic transmission. Fruit bats are believed to be the natural reservoir, with humans contracting the virus through contact with infected animals such as bats, primates, or forest-dwelling wildlife. Outbreaks often begin in rural villages with limited healthcare infrastructure, making early containment challenging. Once introduced to humans, Ebola spreads through direct contact with blood, secretions, or contaminated surfaces, particularly affecting caregivers, healthcare workers, and family members. Its high fatality rate and rapid progression create fear, social disruption, and a pervasive sense of urgency wherever it appears. The societal impact of Ebola has been profound. Outbreaks disrupt community life, education, trade, and healthcare delivery. Fear of contagion often leads to the abandonment of sick individuals, flight from villages, and breakdown of traditional social support systems. Funeral practices, which involve close contact with the deceased, have historically contributed to transmission, necessitating sensitive adaptations to cultural norms in public health interventions. Ebola exposes not only biological vulnerabilities, but also social and cultural challenges in responding to highly contagious diseases. The 2014-2016 West Africa Ebola epidemic represents the largest and most devastating outbreak in history. Centered in Guinea, Liberia, and Sierra Leone, the epidemic infected over 28,000 individuals and caused more than 11,000 deaths. Weak healthcare systems, urbanization, and international travel facilitated the spread, while misinformation and distrust of authorities complicated containment efforts. Global response included rapid deployment of medical personnel, establishment of treatment centers, and experimental use of vaccines, illustrating both the challenges and potential of international coordination in managing deadly outbreaks. Ebola also catalyzed advances in medical science and public health. Research into viral pathogenesis, transmission, and immunology accelerated during outbreaks, leading to the development of diagnostic tools, antiviral therapies, and vaccines. The RVSV ZBOV vaccine, approved in 2019, represents a major breakthrough, offering high protection and the ability to control future outbreaks. Ebola demonstrates how emergent zoonotic diseases can stimulate rapid scientific innovation and the development of global health infrastructure. The economic consequences of Ebola are significant. Outbreaks disrupt agriculture, trade, and labor markets, while the costs of medical care, international intervention, and containment measures are immense. Local economies often suffer long-term setbacks due to loss of workforce, reduction in consumer activity, and strain on public services. These economic effects underscore the intertwined nature of health and development, highlighting the need for resilient healthcare and social systems. Culturally, Ebola has reshaped perceptions of disease, hygiene, and community responsibility. Education campaigns, often delivered through radio, community leaders, and healthcare workers, have emphasized hand hygiene, safe burial practices, and early reporting of symptoms. Communities have adapted, demonstrating resilience, cooperation, and innovation under extreme pressure. Ebola reminds us that effective public health responses must consider not only the biology of the pathogen, but also the social context in which it operates. Ebola's persistence and periodic resurgence highlight the ongoing threat of zoonotic diseases. Human encroachment into forested areas, bushmeat consumption, and global travel increase opportunities for virus spillover, making vigilance essential. The virus exemplifies the complex interplay between environment, human behavior, and pathogen evolution, demonstrating that public health preparedness is not solely a scientific challenge, but also a societal and ecological one. In conclusion, Ebola is a stark reminder of humanity's vulnerability to emergent pathogens. Its high fatality, rapid transmission, and societal disruption make it a formidable adversary, yet its history also demonstrates human resilience, innovation, and cooperation. From early outbreaks in remote villages to the massive West African epidemic, Ebola has driven advances in medical science, public health, and global health governance. Studying Ebola provides insights into the dynamics of zoonotic diseases, the importance of culturally sensitive interventions, and the critical role of preparedness and international collaboration. The story of Ebola illustrates that while viruses can challenge human societies profoundly, our collective knowledge, adaptation, and solidarity remain powerful tools in confronting the microscopic threats that continue to shape our world. While many pandemics are transmitted through human to human contact, a significant group of modern viral threats spreads through mosquitoes, creating unique global health challenges. Zika, dengue, and chikungunya illustrate the devastating interplay between vector biology, climate, urbanization, and globalization, reminding us that disease transmission is often a complex ecological puzzle. Zika virus first emerged in Uganda's Zika forest in 1947, but it remained relatively obscure for decades. Its explosive spread in the Americas during 2015 to 2016 captured global attention because of its severe consequences for unborn children. Pregnant women infected with Zika risked giving birth to babies with microcephaly and other neurological defects, raising urgent questions about reproductive health, prenatal care, and public health interventions. Beyond congenital effects, Zika can cause Guillain-Barré syndrome, a rare but serious neurological disorder. Transmission occurs primarily via Aedes mosquitoes, which thrive in tropical urban environments, though sexual transmission is also possible, complicating containment efforts. Dengue fever, sometimes called breakbone fever, has long been a tropical scourge, with outbreaks documented in Asia, Africa, and the Americas. Dengue infects millions annually, causing high fever, severe joint pain, rash, and occasionally life-threatening hemorrhagic complications. Its global spread is fueled by urbanization, travel, and climate change, which expand mosquito habitats. Despite decades of research, dengue remains largely uncontrolled, with vaccines and vector management representing critical but imperfect tools in the fight against this persistent pathogen. Chikungunya, first identified in Tanzania in the 1950s, causes fever, rash, and debilitating joint pain that can last months. Like Zika and dengue, it spreads through Aedes mosquitoes and has caused outbreaks in Africa, Asia, Europe, and the Americas. Its rapid spread into new territories highlights the risks of global connectivity, climate shifts, and urban crowding. Collectively, these mosquito-borne viruses illustrate the challenges of controlling pathogens with environmental and behavioral components. Unlike influenza or SARS, human behavior alone cannot fully contain these diseases. Vector ecology, climate, Patterns and urban infrastructure play central roles. Public health responses must combine mosquito control, community education, vaccination where available, and international surveillance. These viruses also highlight the growing intersection of climate change and global health. Rising temperatures, altered rainfall patterns, and increased urbanization expand mosquito habitats, creating new opportunities for disease transmission. The story of Zika, dengue, and chikungunya demonstrates that modern pandemics are not always explosive global crises, but can quietly spread, leaving long-term societal and health consequences. They remind us that vigilance, science, and adaptation are essential in a world where microscopic threats are ever present, often shaped by the ecosystems we inhabit and the lifestyles we lead. Influenza viruses are not confined to humans. They circulate widely among animals, sometimes jumping species to ignite global crises. Avian and swine influenza exemplify the dangers of zoonotic spillover, revealing the delicate balance between ecosystems, human activity, and viral evolution. Avian influenza, commonly known as bird flu, primarily circulates among wild birds, but occasionally infects domestic poultry and humans. The H5N1 strain, first identified in humans in 1997 in Hong Kong, alarmed global health authorities because of its high fatality rate, over 50% in confirmed cases, while human-to-human transmission remained limited. The virus highlighted the pandemic potential of influenza viruses crossing species barriers. Outbreaks often devastated poultry industries, forcing mass culling and disrupting economies, while also raising fears of a mutation that could trigger a full-blown human pandemic. Swine influenza, including the infamous H1N1 strain, emerged from pigs as a mixing vessel for influenza viruses. The 2009 H1N1 pandemic illustrated how quickly a novel strain can spread in a highly connected world, infecting millions and causing widespread illness and death. The virus combined genetic material from avian, swine, and human influenza strains, demonstrating how animal reservoirs serve as laboratories for viral evolution. Rapid detection, vaccination campaigns, and global coordination helped contain the pandemic, but its impact highlighted vulnerabilities in surveillance and healthcare preparedness. Both avian and swine influenza demonstrate the critical role of human behavior in disease emergence. Intensive farming, wildlife trade, and habitat encroachment increase opportunities for cross-species transmission. Global travel accelerates spread, turning localized outbreaks into international concerns within weeks. These viruses underscore the intersection of ecology, economics, and public health, emphasizing that modern pandemics are not purely medical challenges. They are ecological and societal as well. Preventing animal origin influenza requires coordinated efforts, veterinary surveillance, biosecurity measures, vaccination of livestock where feasible, and early warning systems. Public awareness campaigns and international collaboration are crucial, as delayed recognition or misinformation can amplify both health and economic consequences. In conclusion, avian and swine influenza are vivid reminders of how interconnected humans, animals, and the environment are in shaping pandemic risk. Their history illustrates that microscopic threats often arise from the natural world, but proactive science, surveillance, and cooperation can prevent localized outbreaks from becoming global crises. These zoonotic influenza viruses remain enduring warnings that human innovation must continuously adapt to evolving microbial threats. While viral pandemics often dominate headlines, a quieter but equally menacing threat has emerged in the form of antibiotic resistant bacteria. These superbugs represent a slow moving pandemic, silently undermining the foundations of modern medicine and threatening our ability to treat even routine infections. Unlike influenza or Ebola, antibiotic resistance develops over time, driven by evolutionary pressures, human behavior, and misuse of medical interventions. The story begins with the discovery of antibiotics in the 20th century. Penicillin, introduced in the 1940s, revolutionized medicine, turning previously lethal infections into treatable conditions. However, bacteria are highly adaptable. Overuse and misuse of antibiotics in medicine, agriculture, and livestock production created selective pressure for resistant strains. Bacteria, such as Staphylococcus aureus, evolved into methicillin-resistant strains, MRSA, while Escherichia coli, Klebsiella, and Mycobacterium tuberculosis developed resistance to multiple drugs, creating life-threatening challenges in hospitals and communities worldwide. Antibiotic-resistant infections cause prolonged illness, increased medical costs, and higher mortality. In hospitals, superbugs spread rapidly among vulnerable patients, particularly in intensive care units. Surgical procedures, chemotherapy, and organ transplants, once relatively safe, become riskier when bacteria can no longer be reliably treated. The World Health Organization considers antibiotic resistance one of the greatest threats to global health, emphasizing that without effective antimicrobials, decades of medical progress could be reversed. The societal impact of superbugs extends beyond health. Economies suffer as prolonged hospitalizations, loss of workforce productivity, and higher treatment costs accumulate. Agricultural practices where antibiotics are used to promote livestock growth contribute to the problem, illustrating how industrial systems intersect with microbial evolution. Public awareness campaigns, stewardship programs, and strict infection control measures are increasingly critical to prevent further escalation. Scientific innovation offers hope. Research into new antibiotics, alternative therapies, bacteriophages, and vaccines aims to stay ahead of evolving bacteria. Yet, the challenge is ongoing, as bacteria evolve faster than the drugs designed to kill them. Superbugs highlight the evolutionary arms race between humans and microbes, reminding us that the microscopic world is dynamic and resilient. In conclusion, antibiotic resistant bacteria represent a silent pandemic, one that progresses gradually but with profound consequences. Unlike sudden viral outbreaks, superbugs challenge healthcare systems over decades, threatening the efficacy of modern medicine. They underscore the critical importance of responsible antibiotic use, global surveillance, and continued scientific innovation. Understanding and addressing this silent pandemic is essential for protecting both current and future generations from preventable suffering and death. As humanity moves further into the 21st century, the dynamics of pandemics are changing, Globalization and climate change are no longer abstract concepts. They are active forces shaping how diseases emerge, spread, and affect societies. Understanding these factors is crucial to anticipating and mitigating the pandemics of the future. Globalization has made the world smaller and more interconnected. Rapid international travel, global trade, and dense urban centers allow pathogens to traverse continents in hours. The COVID-19 pandemic illustrated this vividly, with a virus originating in one city spreading worldwide within weeks. Modern supply chains, airports, and mass transportation facilitate the movement of both humans and disease vectors, creating conditions for outbreaks to escalate into global crises. Even diseases previously considered local or contained, such as Zika or Ebola, now have the potential to impact distant regions due to this interconnectedness. Climate change further complicates the picture. Rising temperatures, altered rainfall patterns, and expanding urbanization change the habitats of disease vectors like mosquitoes, ticks, and rodents. Regions previously free from diseases such as dengue, chikungunya, or malaria are now at risk. Melting permafrost may even release ancient pathogens previously locked away for millennia. Climate-related disasters, floods, hurricanes, and droughts displace populations, disrupt healthcare systems, and create conditions conducive to outbreaks of waterborne and vector-borne diseases. The combination of environmental shifts and human behavior makes pandemics increasingly unpredictable. Human encroachment into wildlife habitats also fuels the emergence of zoonotic diseases. Deforestation, intensive agriculture, and wildlife trade increase contact between humans and animals, providing opportunities for viruses and bacteria to jump species. Many recent pandemics, including SARS, MERS, and COVID-19, have roots in zoonotic spillover, demonstrating the ecological dimensions of disease risk. The future of pandemics depends on preparedness, surveillance, and cooperation. Scientific innovation, rapid diagnostics, vaccines, antiviral therapies, and genome sequencing is critical. But equally important are public health infrastructure, education, and global collaboration. Understanding the ecological, social, and economic drivers of disease can help prevent localized outbreaks from becoming global catastrophes. In conclusion, globalization and climate change are redefining the landscape of pandemics. The microscopic threats that have shaped human history now intersect with human behavior, environmental change, and technological advancement. The pandemics of the future will not only test medical systems, but also our ability to adapt societies, protect ecosystems, and respond collectively. Humanity's resilience will be measured not just by scientific breakthroughs, but by our capacity to understand and act in an increasingly interconnected and changing world. Throughout history, pandemics have shaped humanity, revealing both our vulnerabilities and our remarkable capacity to adapt. From the Black Death to COVID-19, each outbreak has taught critical lessons about science, society, and the environment, highlighting patterns, mistakes, and strategies that continue to inform public health today. One of the most enduring lessons is the importance of early detection and rapid response. Historical pandemics, from cholera to influenza, demonstrated that delays in recognizing disease outbreaks allow pathogens to spread unchecked. Modern surveillance systems, genome sequencing, and global health networks aim to close this gap, enabling faster containment and intervention, transparency, and data sharing, as seen during SARS and COVID-19, are essential for effective response and international coordination. Another critical lesson is the interconnection between society and disease. Urbanization, trade, travel, and social inequalities amplify pandemics, while robust infrastructure, hygiene, and equitable healthcare reduce their impact. Pandemics are not purely biological events. They are social phenomena. Public health is most effective when it addresses behavior, education, policy, and access, not just medicine. Vaccines and medical innovation remain cornerstones of pandemic control. Polio, smallpox, and COVID-19 demonstrate humanity's ability to confront even highly transmissible pathogens with science. At the same time, the rise of antibiotic resistance and emerging zoonotic diseases reminds us that pathogens continually evolve, and innovation must keep pace. Global cooperation and preparedness are essential. No country is immune in an interconnected world. International organizations, cross-border research, and shared resources are vital to combat pandemics effectively. History shows that isolation or delayed response worsens both human and economic tolls. Finally, pandemics reveal human resilience. Communities adapt, innovate, and recover. Cultural shifts, social solidarity, and collective action have repeatedly mitigated the worst consequences of disease. The endurance of public health systems, scientific inquiry, and civic responsibility illustrates that humanity, while vulnerable, is also capable of extraordinary adaptation and foresight. In conclusion, pandemics are a constant reminder that microscopic threats profoundly shape human history, society, and progress. Learning from the past, investing in science and infrastructure, and fostering cooperation will determine how well we confront future outbreaks. The human fight against pandemics is ongoing, a testament to our curiosity, resilience, and unyielding drive to survive in a world where microscopic adversaries are ever present. Each outbreak leaves lessons, and each lesson strengthens the global community's capacity to protect life, health, and civilization itself. Now, with a smile on your face, you will have a good understanding of pandemics and viruses and a good night's sleep. Goodbye, dear friend. See you next time.